Now, coming to the solution itself, the Lego Computer Science AI solution, this solution is a hands-on, understandable, and safe for every student. So, what happens, or what is the thing that Lego Computer Science and AI solution is bringing on the table for educators is that students will experience AI in a very safe and understandable manner. So, as you can see, the first thing that would be um, that students would understand about AI is that we'll have to demystify how AI works. So that would be done by experimenting with core AI concepts. More importantly, when we talk about the core AI concepts, we'll have to understand that children's at different age groups perceive and consume AI at different levels. So it is very important to have age-related concepts that is taught according to the age band. And second of all, it should also be highly visual activities. So what Lego Computer Science and AI solution brings on here is that it brings on age appropriate concepts, AI concepts specifically, and also highly visual activities that makes complex AI concepts tangible for students to understand on a higher basis. Second, the result of this particular approach of learning AI is that it will not just bring AI literacy to students, rather it will also help students how AI works in real world and how they can interact with AI to create their own projects and own activities and test different models in the classroom environment. Moving on, with this particular kit or this particular solution, there are three layers in which LegoEducation has designed the entire framework and the lesson plans. So the first layer of this is to understand the AI using safe and secure practices, and also making sure that the AI tools that are readily available for students to use and teachers to teach is easy to use. So in this particular point, what actually happens is that when we talk about safe and secure use of AI, everything related to AI activities that the students will interact with will run locally on the students' devices. So that is the first important thing that this particular solution is bringing onto the table. So when we talk about running locally on the students' devices, no data collection happens, no data validation happens, and there is no login or anything for that sort of matter. So what happens is there is no data collection, so students can need not worry about their data privacy and all those issues. Second, concepts. The concepts that are taught on this particular AI kit is that we will talk about computer vision. So students will understand how computers see the world. Second, classification of data, how data is classified by computers using computer vision. And finally, probabilistic thinking. So with probabilistic thinking, students will also understand how an AI system is making a decision based on what it sees. So basically, using computer vision, AI classifies data, and with that classification, it goes on to uh, take a decision based on the probabilistic thinking concept. And finally, inputs. So the inputs that the students would be giving using the AI concepts would be based on cameras. So using the devices, onboard devices cameras, like laptops or iPads or whatever it is, students will be interacting with AI models based on body pose detection and also body sensing features. And with these two AI capabilities or AI features that are there in the kit, what students will also understand is that they will go on to a hands-on approach to understand how AI reads, interprets, and classifies human movements. So that would be the three-layer approach that computer science AI kits from Lego Education is going to be about. So when we talk about the core design principles behind designing this AI solution, computer science and AI solution from Lego Education is that when we talk about safe and secure AI, I already have addressed it. So all the AI features that comes along with this kit on the coding canvas where the students will interact with the AI models will be run locally on the student devices and no data is transmitted to anywhere. So even in local devices, the data is not stored. It is not getting into the Lego Group's servers or anywhere. And another way it is from which we'll be easily understanding that there is no data collection happening is The portal through which we will be accessing the coding canvas does not come with any logins. So there is no requirement for a user to go ahead and create their IDs using their email or whatever it is. So it is a direct website through which you will be able to program your AI models. Second, all personally identifiable information will be from the device's camera, and there is a filter that is layered onto the camera. So what happens is who is in front of the camera will not be directly visible on the output. So there will be a blurred version of the person who's there in front of the camera. So what happens, or what is the advantage with this particular system is that given the market that we are in and the region that we are in, it is very much important that students needs to be comfortable to stand in front of the camera in case if they want to interact with any AI models. So that has been already taken care of. And more importantly, when we talk about the easy to use feature, the user interface is designed in such a way that whatever the AI system is looking at, it is easily transferred. The information that the computer is looking at is easily perceived by the user also. So the user interface is designed in such a way that whatever the computer is saying or whatever the data the computer is trying to read and interpret, the same is translated to the human so that the humans are also able to understand it very easily. And most of the things when we talk about these two AI features that are enabled in the coding canvas are interactive. So which means you need not worry about adding blocks to check if the AI features are working. Rather, as soon as you open the coding canvas and enable the AI blocks, what happens is you will be able to see the live data that is the AI system is looking at, and you will be able to view it and try to respond to it as well. Now, coming to the second layer of this AI system is that there are three important things that we talked about. One was computer vision features, the second one was classification, and then probabilistic thinking. So when we talk about computer vision, whenever camera is involved in AI, computer vision is one of the core concepts that makes AI possible, right? So what computer vision means here is that the way the computer perceives the environment and tries to understand how um, it looks at the world. So that is what is something that we will be covering in Lego Computer Science and AI concepts as well. So computer vision is explained to students where they will understand how a computer system will understand the real world. Second, they will talk about, or the concepts will be covering classification of different classes. So depending on what the computer vision is looking at, the classification of data is happening. And from there, probabilistic thinking happens. So what happens with thinking is that students see the AI does not give yes and no answers, but rather it works with a probabilistic range of values. So it will try to relate to the closest value it is looking at, and it will be trying to segregate to the closest number it is able to come up with based on the probability level that it is trying to understand from the computer vision. Now, moving on to the final layer, where students will be actually interacting with AI and trying to understand the two important AI features that are in the coding canvas. First one is your body sensing AI. Second one is your post classification tool. So here also, since this kit starts from KG to grade 8, we should understand what level of AI should be introduced to which age band. So here, if you see, there is a progression that is also given, and the complexity of the AI tools that the students will be using is also increasing progressively depending on the kit that we are using. So the first kit, that is grades K to KG to grade 2 kit, will be working on pre-trained classifiers. So which means there are no classification that the students will create. Rather, they will interact with classifiers that are already being created in the coding canvas. So what students will do is they will use the body sensing feature, go in front of the camera. They will try out different body poses that has been pre-trained in the coding canvas, and they will try to interact with it. Second, when we go to the next age band, that is grade 3 to grade 5, what students will do here is they will go one level above. Apart from interacting with the pre-trained classifier, they will also go ahead and create custom classifiers. So when we talk about custom classifiers are nothing but students will create their own classes and train those classes with data. Now, one good thing in this particular feature is that when students are taking pictures of themselves or any poses or anything that they are doing in front of the camera, will not be translated as direct image of the student. Rather, it will be taken as a stick figure image. So as you can see on the screen, the second image, that is 3 to 5 image, the progression. The person who is standing in front of the camera is raising his hands, but the data that is collected by the computer is not the person itself, rather it is taking the pose of the person. So the custom classifier, even though it is using camera to capture the poses of the students or the person who's standing in front of the camera, it does not actually take the picture of the person itself. So again, the data privacy is protected over here, and data collection is also not happening. It is just stick figures that are collected and shown on the screen. And finally, for the highest age band, that is grade 6 to 8, there is a new AI tool that is being introduced that is called the body sensing AI tool. So apart from the pre-trained classifier and the custom classifier, they will also be introduced to body sensing AI tool, where students can explore an even more detailed or advanced version of AI, where this particular AI will be able to track pupils, nose position, ear position, your arms, wrist, shoulder, elbows, everything. So with this, students will be able to customize how their AI models or the models that they are building will work depending on different actions or different angles or different um, positions of the organs in front of the camera. So that would also be something that the students can explore. So as you can see, it is a progressive nature. So AI is introduced for K-2. So they'll be just introduced to the concept of AI, how AI works using pre-trained classifier. For grades 3 to 5, they go a step above where they create their own classifiers. And finally, in grade 6 to 8, apart from creating their own classifiers, they will go ahead and use an advanced AI tool, which is called the body sensing AI tool, and they'll be trying to create advanced projects. So with this in mind, what I'm going to show you right now is a lesson in action. So what I want you to do is just pay attention to the video that is shown to you. What this video explains about is how a typical computer science, Lego computer science and AI lesson would look like inside a classroom scenario, how a teacher would conduct a successful lesson where they explain the concept of computer science or AI and guide the students through the activity on a hands-on learning approach.
Ready to excite your students with computer science and AI? This lesson is called Strike a Pose. Students will learn how to customize an AI classifier and program AI-activated events. We'll kick off with a big question to spark curiosity. How could you train a robot to follow your movements? We will explore the topic through the computer science concepts, AI, and data. The question is tied to a real-life example, how AI can be trained to recognize images through data. This makes it more relatable to both students and teachers. In groups of 4, each student picks a minifigure, which indicates their roles in the collaborative building process. The group will build a robot with movable arms and discuss how it might work. Then it's time to get hands-on with coding. Groups will open LegoEducation coding canvas, enter the lesson pin, and connect their hardware. Students create and train their own AI custom classifier by posing in front of the camera and capturing pose data. With simple pre-made code and their classifier, groups explore making the robot mimic their arm poses. Group members take turns so everyone gets hands-on. 2 students develop the build of the robot while the other 2 iterate on their code and later they swap. Students present their robot, talk about their iteration process, and discuss how they created and trained their class. At the end of this lesson, students will be able to say, I can create a custom classifier. I can use pose data to train a custom classifier. I can describe how to create a custom classifier and use data to train it. This is the third of 4 lessons in the AI and data unit. where students explore how computers learn from data. In the following lessons, students investigate how data quality and quantity can improve how their AI detects their poses. At the end, they apply what they've learned through an open-ended design challenge. All materials for this lesson can be found on the LegoEducation Teacher Portal lesson plan, ready-to-use classroom presentation and facilitation notes. No extra prep time needed.
Yes. So as you would have seen from this video, the typical classroom experience itself is focusing more on hands-on approach towards computer science and AI concepts learning. So what happens is that, as you would have seen in the video, it starts with an open-ended question. The teacher comes up with an open-ended question that relates to the concept with the real world. And after there is an open-ended discussion, what happens is they go on to the concept of the day and then they go on to the building. So the building here is a little bit different. What happens here is there are four students that will share the kit, and each student will be responsible for their own builds, and then they collaboratively put together all of their builds into one single model. Once the model is built, what happens is students go into the coding phase where they implement a set of code based on the concept that they have learned. So let's say they are talking about loops or conditionals. So the concept is taught by the teacher. Once the concept is discussed, the program is explained. And once the program explanation is done, the students will go ahead and test the program on their model to see how the concept of that particular programming works. Once this is done, what happens is there is an additional stage where there is an open-ended um, task that is given by the teacher where the students can go ahead and explore how to modify that model and also the program to see if there is any change in action to the model will happen depending on the change in the program, so that there is reiteration of the concept again. And finally, they end with an open-ended discussion, and there is observation, and then the lesson is done. All these lessons are planned for about 40 minutes to 45 minutes of session. So now coming to the kits itself. So we have so far talked about how the concepts of AI are introduced to students at different levels, how computer science and AI concept would be taught inside a typical classroom experience with Lego computer science and AI kits. Now, when we talk about the kits itself, the kits come with three different levels, and as I mentioned earlier, it is a K to 8 solution. You have three kits, one kit for grades KG to grade 2, the second kit is for grades 3 to 5, and the final kit is for grades 6 to 8. Now, all of these kits individually come with 30 lessons each. So overall, you have about 90 lessons that equates to about 160 hours of learning. So these lessons not just focuses only on computer science concept, they also talk about AI literacy concepts, just like as we discussed earlier. And apart from these core concepts of computer science and AI, these kits also simultaneously cover key important 21st century skills like data analysis, algorithms and programming, networks and the internet, impacts of computing and computing systems simultaneously. And when we talk about the concepts, as you all know, computer science concepts do not change depending on the programming language or the tool that we are trying to use. The concepts remain the same. So what Lego Education has done here is that based on the age band, they have taken clear cut concepts and they have mapped the concepts to different kits based on the complexity level. So, for example, if you see here, the grades 3 to 5 kit focuses on six important concepts of computer science like basics, the events, loops, conditionals, variables, and finally AI and data. Now, each of these six units, so 6 units per kit, so 30 lessons in total, so which means that every unit will have 5 lessons. And these 5 lessons are structured lessons which has a certain format, which I'll be discussing in a few minutes. But to give you an overall idea about the kits, as you can see, the segregation of the concepts is like this. So in case if you want to take a screenshot or a picture of how the concepts of computer science and AI is segregated between the age groups, you can go ahead and do so. What we will do at the end of the webinar is also that we will send you the resources to access the lesson plans, access the coding canvas, and all other things that you would want. So moving on, the concepts that you would have seen. So for example, from the previous slide, you see loops is a concept that has been covered across the kits. So it starts from K2, it goes to grades 3 to 5 as well as 6 to 8. So how that is done here itself is that there's a progressive learning approach that has been taken into consideration right from the first kid to the third kid. So students, when we talk about loops, they are introduced to simple loops in the youngest age group. And then in grades 3 to 5, they get into indefinite loops using the formal loops. And then finally, in the highest age group, they get into nested loops. So this is how each and every concept in computer science and AI, in Lego Education Computer Science AI Kit, is designed so that there is a progressive and there is a spiral learning approach that is happening. Next. As I mentioned, each concept of computer science here is considered to be a unit. So each kit comes with 6 units. So here, if you see, I have taken the example of grades 3 to 5 kit. It comes with 6 units. The first unit is basics. Second unit is events, loops, conditionals, variables, and finally AL data. If you look at events unit, as I mentioned earlier, every unit has 5 lessons in them. So if you see the 5 lessons here, the first 2 lessons will share the same model and students will be introduced to the concept of events on a lower level. And in the next 2 lessons, lesson 3 and 4 will share again the same model. So which means there's a common model for the first 2 lessons. There is a common model for lessons 3 and 4. And in lessons 3 and 4, there is a progression happening where they'll be diving deep into the concepts of events. And then finally, the fifth lesson is a design challenge, where the design challenge will go on for 40 to 45 minute sessions. So in the design challenge, what happens is there is no structured learning happening. When I say structured learning, lesson 1 and 2 follows a structured learning where there's a structure for the lesson. Students are given a building instruction. Students will go as a group and build the model, and they will test the model using the concept of events. Again, in lesson 3 and 4, there's a guided building instruction. Students will go for the building phase, they build the model, and then they test the model with the concept that they have learned in lesson 3 and 4. And then finally, in design challenge, you might think, okay, Lego is known for their creative approach to education. But here, when we are talking about structured way of building stuff, that might be diluted. But that is not the case because in lesson 5, students will be exploring a design challenge. So what happens in design challenge is that there is an open-ended question. There is a challenge that is given to the students. So there is an open-ended challenge for the students to go ahead and build a model of their way. They can discuss, they can collaboratively build the model and then try to implement the concept of events and basics to show or while programming the model. So that is how the fifth lesson is taken care of. So each unit has 5 lessons, 2 plus 2 plus 1. So the last lesson will go on for 2 40-minute session. That's how the structure of each and every unit is there. And this is common across all the kits. Now, when we talk about the lesson plans itself, as you would know, Lego Education is known for their 5E framework. They are carrying forward the same 5E framework with Lego Computer Science and AI solution as well. So the first E stands for engage, where there's a big question which is open-ended, where students try to talk about, or the teachers try to talk about a concept that is relating to the real world. And then they go to the exploration phase where they build a model together and then predict what the model might do depending on the concept that is introduced to the student. And then there is an explanation phase where the students go ahead and explore the coding and then they try to explain what the code translates to the model. And then they move on to the elaborate phase. What happens in the elaborate phase is that students go ahead and tweak the model or the code depending on their choice and see what or how does the change in the model or the code affects each other. And finally, the evaluation phase where students try to come up with different ways. For example, let's say there is a classroom of 24, you will have 6 different groups. 6 different groups, when they go to the elaborate phase, they will have different ideas to tweak the code. So what happens in the evaluate phases, they try to self-reflect on which among the 6 models has more functionality, more changes into the code, and how it has affected their models themselves. And finally, they share their ideas and projects to the classroom and get feedback from peers. And here is some of the lessons and their models from different age groups. For example, if you see the first lesson over here, the behavior lesson, the concept that is covered over there is events, that is from grades 3 to 5 kit. The next one, if you see the art designer, that covers the key concept of functions, and that I think is from grade 6 to 8. Dragon Defense is from 3 to 5, which covers concepts of loop. And then finally, Music Machine is again a concept of function that is from 6 to 8. Now, if you see here, all the models are drastically different to each other. And one might wonder, how am I going to cover a computer science concept using this particular model? Now, that is where your lesson plans and your guided instructions will help you as educators to go ahead and transfer this particular lesson in an effective manner. And students, when they see these kind of models, their interest level also intrigues. So they would want to test out what the model would do based on the concept that you're teaching them. And one another thing that I want to highlight with this particular set of lessons is that each and every model is drastically different to each other, as you see. And another important thing that LegoEducation CS and AI solution also covers is that it focuses on multiple intelligence theory also. So there will be different types of learners in different classrooms. So some would be kinesthetic learners, some will be musical learners, some will be visual learners. So based on different types of learning, you can see there are different lesson plans that caters towards to this multiple intelligence theory also. So once you go through the portal and see the different lesson plans, go through the lessons and the models themselves, you yourself would be amazed to see the way in which these models vary in design from each other and how these models translate a computer science or an AI concept into action into a classroom. So to summarize about the kits itself, so we talked about the kit, how the kits are segregated, how the lessons are segregated, how the concepts are segregated. But each kit has physical variations as well, which is what we'll be looking at now. So the first kit, which is the KG to grade 2 kit, comes with two electronic components. One is a single motor, as you can see on the screen, that is a single motor. And then it also comes with one color sensor. And then there is one connection card. So a connection card is nothing but it can form connection between two electronic devices seamlessly by just tapping them. Next kit, which is the grades 3 to 5 kit, comes with one double motor and one color sensor. And then it also comes with one connection card. Finally, the highest age band, that is your grade 6 to 8 kit, comes with all the electronics, one double motor, one single motor, one color sensor, and also a controller. So apart from this, you also get two connection cards with this particular kit. So this is the classification of the kits themselves. The first kit comes with simple electronics. So as you can see, depending on the age group, the complexity of the electronics also changes. So based on the electronics that is there in the kit, the lesson type also changes. So that is how the progression is clearly mapped for educators. So it is easy for anyone to teach these computer science and AI concepts inside your classroom. Now, as apart from the kids, we were talking about different other things, how educators can use this solution inside the classroom effectively without any hiccups. So there is a dedicated teacher portal from which you will be able to access all the lesson plans that you would want. So the teacher portal is free to use, of course. You just have to create an account. You get into your account, you will be able to see the computer science category. So under computer science category, you will be able to pick the kit that you're using, either it is grades 3 to 5, 6 to 8, or grades KG to grade 2. And then you'll be able to pick the unit that you want to teach and then the lesson. And once you get into any of the lessons, so for example, here I'm in a lesson of loops that is covered in grades 6 to 8 age group. And then if you see the lesson name is called drop from the top, you can see there are three important things that is there in front of you. One is the classroom presentation. So the classroom presentation is the only tool that a teacher or an educator would need to cover this particular concept or any particular concept from this particular kit. So what happens is the classroom presentation is run throughout the session, throughout the entirety of 40 minutes. And there are various concepts, various ways in which you will be able to guide the students to the concept. And then in case if you need more prep for your class, there is facilitation notes which will help you to prepare for your class. And then finally, in case, let's say that you don't want to go for building instructions from the book that comes along with the kit, you would want to do it online or do you want to use the e-version of it, there is also building instructions for you that is readily available. Right. Now, looking at the coding canvas. So the coding canvas, this is on a nutshell how it looks like. You have different coding blocks that are readily available for you on the left side, in which you will be able to access the blocks and then try to use it. It is just a very simple drag and drop interface. And depending on which lesson you are in, you will be able to access specific blocks. In case if you want to use the entirety of the blocks, that is also possible. You just have to go to the coding canvas and enable all blocks feature, then you'll be able to access all the blocks. Now you can see here in this example or in this screenshot, the program that we have added is to control or to use post classification AI model that is present in the coding canvas. And just you can see here the person who is in front of the camera, it is not detecting the person, rather it is just detecting the shell out of the person and trying to map a stick figure to the shell out of the person. Right. And another important thing, this coding canvas can be also has a feature called enter pin feature. So when you are in the coding canvas in the home page, you'll have to enter the lesson pin. So what does a lesson pin mean here is that, so every lesson that you are trying to teach, either from computer science or AI, will have a sample code readily available for you to use or test out. So to access the sample code, if you enter the lesson pin, that particular code for that particular lesson will be loaded up for you on the coding canvas as soon as you enter. So this set of code that you see right in front of the right in the screen is basically a lesson from one of the lessons in AI concepts from the 6 to 8 age band. Now, coming to the infinite possibilities. So everyone must have, there's a lot of buzz about these kits online because educators and people who have seen this kit and seen multiple videos and launches from Lego, and there are different information that has been passed on from different parts on social media, on professional media, on educational platforms. You have observed that there are different news that is being released. So there is a question that arises with everyone. So what can I do with this kit apart from the 30 lessons that comes along with it? Can I do something crazy with it? Can I do something is beyond the 30 lessons that is readily available for me to use? Can I enable my students to build something that is more complex and more fun to actually work with and bring that creativity factor into the classroom? To answer your question, yes, definitely that is possible. So how it is achieved is a concept of discussion. First, as I mentioned, every unit of CS and AI comes with one design challenge. So these design challenges is there to push the boundaries of creativity for the students, so that there are open-ended challenges where students come up with their own solutions to a problem and then try to implement the concept of computer science or AI into that particular model. Second, the first Lego League Future Edition is coming up. So that uses these kits that are these kits in the sense the Lego computer science and AI kits, which will be focusing on hands-on and cross-curricular approach where it connects to real-world STEM concepts and STEAM concepts, and they'll be exploring the first Lego League in a very different perspective. So that is extended possibilities that is there. And third thing, if you are wondering what are the different ways I can program, obviously there is icon-based programming and block-based programming. Do I have Python? Yes. Python is available as an external package that you will be able to access and program using Visual Studio Code. And you will be able to connect your hardware to Visual Studio Code, and then you will be able to program your devices. Now, this opens a lot of possibilities. As you know, once the hardware is no longer connected to or bounded to one particular software. Now it is connecting to both the coding canvas as well as Visual Studio Code. The possibilities in which you will be able to use these hardware electronic devices is endless. So that is also possible. Using Python packages, you will be able to create more advanced lessons. And finally, you can go ahead and create some crazy builds. You can see the last image. I'm not sure if you are seeing from mobile phones, it will be very small. But if you zoom in on your screen, you will be able to see there is a 6-axis arm that can also be created with these kits. So this is some ways in which you will be able to explore infinite possibilities with this particular kit. You can also try to do it by yourselves also. Now, to show some glimpses of how these infinite possibilities work, I have a couple of videos for you. You can watch it and see how we had pushed ourselves to use these kits to try to create some high ceiling projects for you. So you can see these were two glimpses of how you can push yourself to use these kits to create something more advanced. So one was a 6 degree of
Your
freedom
voice
robotic
again
arm.
gone. Then my mic is on mute. Can you please switch on your mic? Because I am unable to listen to you when my mic is off.
Okay, can you hear me now? Okay, so the first project that you have seen, the video you have seen is a 6 degree of freedom robotic arm, which is programmed and also controller enabled. So you can run it with programming also. You can also use the controllers that comes along with the kits to create it. And finally, one good feature is that it was simulated on Blender and then it was translated into a real world object. And then finally, the next video that you would have seen was a gesture controlled AI car, so which was using the body sensing feature of the Lego CSN AI kits. And we were trying to create a driving car which will respond to steering wheel action that the user is doing in front of the camera. So that gives me a wrap to the kits itself and about how AI is covered, how CS and CS concepts are covered using these kits, how the teacher portal works, how the coding canvas enables you to use programming using two different ways of programming, and also the endless possibilities of these kits. So I'm opening the floor for your questions. If you have, please do shoot them out on to the chat. We will try to answer as many questions as possible. In case if you want to ask questions using the code here, please go ahead and do that as well. You can scan the QR code and you can answer your questions. Okay, for grade 9 to 12 students, what is the progression path after Spike Prime or this CSA solution? Okay, so to answer this question for grades 9 to 12 students, so for basically here, if you look at this particular kit, the progression ends at grade 6 to 8. So what happens beyond that is if you have Spike Prime as a solution that is readily available that you have been using in your school, you can definitely go ahead and progress from there, introducing them to higher concepts of programming using Python programming. If not, you can still use the same kit for your higher age group. You might have to design your own lessons because the lessons that you would be covering for your 9 to 12 students should be a little bit advanced compared to what you are covering from grade 6 to 8. So if you are able to come up with a plan or something like that, then definitely yes, you will be able to use these kits to address the concepts of Python or Python libraries with this kit for your grades 9 to 12 students as well. Any other questions? Regarding the prices of the kits, I think you should reach out to one of our team members where you can fill in your details. Our team will get in touch with you to give the details of the financials of the kits. How much does the kit cost and how does it come? Is it a classroom pack or is it an individual pack or something like that? I can see someone has raised their hand.
Yes, sir. I just need to ask when they can start and what is the duration and uh, how to start. Does they need to have a basic AI knowledge or without any knowledge they can start off?
Yes, as I mentioned, ma'am, this kit, if you see, it starts from KG to grade 2. So there would not be any prerequisite for you to understand how AI works because all these lessons are planned even for a person who does not have any idea about AI. So if you go with the progression right from KG all the way to grade 8, the progression in which the AI concepts are covered is so easy that anyone who does not have any experience with AI also will be able to teach as well as learn. So that should help you out. So I would suggest you to go to the portal, the teacher portal, look through the lessons, see how the lesson plan is done. We will also send you the curriculum mapping of the lessons, how they are mapping into different curriculums as well, so that you can understand how this entire system of 30 lessons is helpful for you. And please, in case if you want a demo of these kits live, you want to see how the kits look like, what are the components that comes inside the kit during a demo, please do scan the QR code and you can book a demo with us. We will definitely help you with the demo as well.
And it is like I'm in India right now, so if they'll be joining from India, so the kit will be sent here.
I think we will get in touch with you to discuss this particular detail because I think my other team members will be the right person to answer this question for you. But if once you fill in the form, we will get in touch with you and we will provide you with required information.
And fee structure, sir?
Yes, ma'am. The financial also about how much the kit cost will also be addressed during the call that we might have.
Okay, thank you.
Thank you.
Hi, Abdul. Good evening.
Good evening. Yes.
Yeah. Actually, you were mentioning about this particular kit will be using for the FLL next season. So at that time, previous time we were using Spike Prime and for 9th to 12th grade of students.
Yes.
Shall we go ahead with the Spike Prime or this particular advanced one? CS and AI.
Okay, so the first Lego League, there is a webinar that is planned for first Lego League also in the future. So we, as an internet team, we organize FLL here in the UAE, of course. So what we are trying to do is we are trying to finalize the event dates and also the details of the event itself. So based on the decisions that we are coming up with, we will be conducting another session where we'll be discussing in detail about how FLL will be. Conducted this year and the next year, and what are the kits that we'll be taking into consideration and how it will be conducted as well. So I think we'll have to wait out for a few more days for us to reveal those information. But in case, in the meanwhile, if you have any doubts about these kits, I'll be more than happy to answer that for you. I'm sorry, I'm not able to reveal much at this point of time. The other details about the FLL will be revealed very soon.
Okay, okay. Thank you, thank you. Thanks so much.
Any other questions from others regarding the kits or the concepts or the portal? Will Spike Prime eventually become obsolete or will Lego continue? Okay. So Spike Prime, as you would have known from Lego, they are stopping the manufacturing of Spike, the entire lineup of Spike itself, not just Spike Prime. Spike Essential will also be stopped from manufacturing, but you will get the parts and spares and support until 2030, and the software support will also be present throughout the time. Yes, is it possible for your team to come in school? Yes, we can come to your school and provide a demo or show the kits to you. Please do register your details using the QR code so that we can get in touch with you. Okay. Thank you so much for joining, guys. Thank you. Thank you for your time. Have a nice day.